Section 2.1, ETL basics. ETL stands for this term called extract, transform, load. This term refers to the general pre-processing step when you want to do with your data. You have a data source either on a file system or somewhere on the internet. Say I want to get the data, extract the data. So you can do a query on a database, or you can make some API calls. You extract the data. The data that you get may not be in the format you want. It may have extra columns. It might have data for the whole world, but you only want a subset of data. It may be in a different projection that you need to do it. So you want to transform it to match the requirement. And finally, load means, let's say you did this, you transform the data, you want to load it into a database. Say my database has a schema, I want to load this, or I want to save it to a local file in this particular format. So this whole process is called ETL, and typically there are specialized tools. There's a tool that GIS people use a lot called FME. So it's a really nice tool, a lot of people like it, but it's a paid commercial tool. You can essentially do your FME workflows using OGR on the command line as a source and free solutions. You can build ETL workflows in QGIS using the models, using the modeler, ArcGIS as a model builder. You can kind of encapsulate a lot of those workflows. But again, rather than doing it in the UI, the advantage of doing the command line is you can run it every 5 minutes. You can run it on a server. You can run it in automated fashion. Okay, so let's learn about those tools here. The problem that we want to solve is we have this CSV file that's in your data package. It's called worldcities.csv. It's a very large file. It's about 13,000 rows. It's a CSV file, so it's a text file. So if I want to open this, this is what it looks like. It's a plain text file. The first row is a header. It says these are the columns. It's got the name of the city, lat long of the city, country, population, and some other attributes. Right? This is a CSV file describing different cities of the world, the lat long, the population, and the countries, and so on. Let's say I want to use this data in my GIS. It's got some useful information. I want to say, I want all the cities in my countries saved to a shapefile. So first I want to turn the CSV into a shapefile. So I want to turn this into a point layer using the lat long columns. I want to turn this into a shapefile from a CSV. Secondly, I want to only select the features which are for my country. I want to drop certain columns. I don't want all the columns. I only want a subset of columns. And I want to do this. We can do this in a single line of command, but we'll do it step by step. We'll learn how the OGR tools work. At the end, we'll have a single command line that will be able to take our CSV and get us a shapefile in the projection that we want for the country that we want, and we can extract the data. Okay, so let's start. We are going to work in the root folder. So in your GDAL tools folder, if you do ls or dir, you should see the worldcities.csv file. Let's run the OGR info command. OGR info worldcities.csv. Similar to how we run GDAL info, you can run OGR info on any vector file. So go ahead, find the data folder, and then just run OGR info space worldcities.csv. We get some information saying that GDAL was able to open worldcities.csv using the CSV driver, and it's got one layer called worldcities. So this means GDAL recognized that this is a CSV file and it opened it, but that's it. We don't really see much information here. Let's look at the documentation for OGR info. This is on the GDAL documentation. We have a section on the vector programs. So we're looking at the OGR info. The way to read this command, it should be familiar to you by now. OGR info, options, 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 data link. Okay, so we just did the first part. We just said OGR info, data source. OGR info, worldcities.csv. And when you do OGR info, interesting, it just opened it. If you want to get some more information about the data, we need to specify some additional options. There is an option called -so, which says summary only. So it'll give you a summary of the data. So typically vector data sets will have different features. We have 13,000 plus features. So we can do -so to say, give me a summary of the data. And the next option that we want to use is this option called -al, which says list all layers. So when we do OGR info, by default, it just says this is a layer. It won't actually open the layer and show you what's inside of that. -al will actually open the layer and show you what's inside. So let's change the command. We'll just say OGR info -worldcities. We can say -al, open the layer, and show me, and then dash SO. So let's add these two options, OGR info dash AL dash SO. And once you're done, press enter. You can see it printed more information about this, because now we said open the layer and give summary. So it says there are 15,493 rows. So we got the feature count and we got the name of different columns. So we got our attribute table. It still says there's no geometry because it doesn't really know how to read the geometry. It's a CSV file. It doesn't know what columns have lat longs and how do we convert this to a spatial layer. Right? I just opened it and give it the summary. Go and remove the dash SO from this command. Just type OGR info dash AL worldcities.csv and see what happens. You say OGR info dash AL worldcities.csv. It prints every feature. It just shows each individual feature saying row number 15,493 is this city and this is the value. And you can see it printed all the information about the city. So if you want to know about each feature in the data, you can just use OGR info dash AL. It's going to open that and show you each feature. This is a great way to say, I have this very large file. I can't even open this in QGIS or ArcGIS. Let me see first few features, what they look like. This also tells you whether the file is valid or not. A great use case of this particular feature is we had somebody who said, we are working with some road network information in the OSM PBF format. This is the OpenStreetMap format, and they wanted to have this. They say we get this PBF files, which are gigabytes in size, very large. If you try to open in QGIS crashes, try some Python tools, doesn't work. We just want to know what country this file belongs to and whether this is valid or not. I just said do this OGR info dash AL in the PBF file. OGR had no problem reading the file. If it's a valid file, it reads it and just prints the command. Just say check the first 10 files, and then you will know which country it is. Right? So OGR can read those very large files very easily. You can kind of check that on the command. Okay, let's turn this. Right now, we don't have a geometry. So we read the CSV file, but we want to assign this some geometry. We know that our data that we have has lat and long. So we can say my X column is this longitude value, Y column is latitude value. How do I say that to OGR? Let's open the CSV driver. Since our source data is CSV, we have to go to the GDAL CSV file documentation and say, how do we tell a CSV file what is the geometry? Similar to with the GDAL commands, if you want to do something with GeoTIFF file, we'll go to the GeoTIFF driver. If you want to do something with CSV file, we'll go to the CSV driver. If you want to do something with shapefile, we'll go to the CSV shapefile documentation. So here, if you come through the documentation, it says building point geometries. If you have points and you have CSV like this, latitude, longitude, you have this option. OGR has this another option called dash OO. Anybody guess what does OO stand for? What would be dash OO? Open options. That means while opening the data set, I want to specify how to open this data set. So these are open options. So this says, while opening the data set, use any column beginning with lon as the X column, any column with lat as the Y column. So CSV file has a lot of open options. If you come here, you can see there are open options. These are the different options you can specify. What is the separator of a CSV file? What is the merge separator, or etc. Right? So these are all the options that you give while opening the CSV dataset. And here it says you can specify this option, X possible names and Y possible names, to tell OGR which is the column containing your X and Y coordinates. Let's do the next step in our course, 2.1.2, where we can say open this SOAL. So open, give a summary, but this time open it with this options. All the columns with L and G, if a column is L and G, that is our X column. LAT is our Y column. Remember, we say lat long, but latitude is Y coordinates, longitude is X coordinate. So you need to specify it correctly. Let's copy this and open this. Remember, when we didn't give this, geometry was none. Let's give our open options. And now when we say open options, we get some extra stuff. It says geometries point, we get an extent. So this is the extent of my full file, because now it's able to open this as a geospatial layer. So I know what the geometries are of each row. Now we get a spatial data. So try this out, run this command in 2.1.2. Again, we are starting from CSV. We're just getting information by assigning some open options. And you can also just remove the summary only and see what happens. I can remove the summary only, and now it prints each row, but it also gives the coordinates of that. You can see there's a point geometry object that comes up. So now OGR is able to read the CSV file, convert the geometry to a point geometry, and read that. So OGR info will just tell you the information. He said, now it's great. We are able to read the CSV as a shapefile or as a spatial layer. Let's just convert it to a different format. So we'll learn about the next utility called OGR to OGR. OGR to OGR is a very powerful command with lots of options. So you can see OGR to OGR, options, options, options. And then finally, we have the data and source. So destination and source. Remember how OGR and GDAL evolved? They evolved separately. OGR was a separate product. GDAL was a separate product. Now they are merged, but again, they have their own histories. OGR to OGR has this notion of specifying the data destination first and source afterwards. Now, GDAL commands will say, GDAL translate source destination. OGR command will say destination source. Just because of the historic reasons, it's that way. And you'll encounter this many times. You are saying, doing some command line, you'll have to remember, oh, it's OGR, so I need to specify the destination first and the source first. We'll learn about a lot of these options through the course. Right now, we can simply say, just read the CSV, convert it to a shapefile or a geo package. Let's see how to do this. So we have our command here. We can say OGR to OGR, open the world cities. This is our source file, open it with this options, and we can turn this into our target file. So we keep our target file first. We'll say world cities.geo package. The geo package is a modern format similar to like a geo database, but it's an open format used by QGIS. You can turn it into a geo package. If you want a shapefile, you can just do SHP. If you want a GeoJSON, you can do GeoJSON and so on. OGR will guess the format based on the extension of the to specify. If you want to be more explicit, you can also give the format code. So if I want to geo package, I can say -f G package. That's a short format code for the particular format. So this says, open the CSV file with these options and turn this into a geo package. Let's run this. We command finished, got a new file, worldcities.geo package. Now this is a spatial data that we can now open in QGIS. Let's open in QGIS. I can drag and drop this geo package, and you can see it loads as a point layer. So this command that we ran turned a CSV file into a point layer and saved it as a geo package format. Okay, try this out and load this into QGIS and see if it loads. You can also open the attribute table, and you'll see that just works like a regular spatial data set where you can see the attributes, you can see the different columns here, and we have the full 15,493 rows that we had in our CSV file. We have one problem though. If you look at the bottom right of QGIS, it says unknown CRS. Well, we assigned it some point geometries, but we didn't tell what is the coordinate system of that X and Y coordinates. If I go back and do OGR info on my worldcities.geo package, and we'll do our -SOAL, it says undefined geographic CRS. So we don't know what is the CRS. So we have some coordinates. We don't really know what is the CRS. QGIS is also not able to recognize what is the CRS. So let's assign a CRS. We tell be explicit and we can say this is our CRS. So back to our command line, up arrow key to go to the previous command, and we just add one option. So let's go to the OGR to OGR documentation. We have some flags which follow the same convention as the other GDAL commands. ASRS, assign and output CRS, but without reprojecting. So similar to GDAL translate, you can say there's an unknown projection. We want to specify what is the projection of this particular data layer. So let's add the ASRS option. You can say this one is EPSG 4326. Back in QGIS, if I load this data layer, you can see now my data loads correctly. It has recognized the projection in EPSG 4326, and now it'll sit correctly on the right place. So try the next command. In section 2.1.3, where we are assigning CRS. Again, we'll end up with a single line of command. We're just adding options step by step, so we understand what each thing is doing. So right now, again, we are starting from CSV, converting to GeoPackage, specifying what columns contain our geometry, and we are assigning this CRS. So we are able to load this data. Let's say my goal is to extract the points of the cities belonging to a certain country. If you look at the attribute table, we have one column called country. We have different countries. Let's say we want to only show data points which are in Japan. So I want to select all points from Japan and only convert those to a GeoPackage. So I have this world layer. I will only select stuff that belong to a particular country. So let's see how we apply that transformation. Section 2.1.4, we have OGR tools which understand SQL. So SQL stands for Structured Query Language. It's a way to query databases, very popularly used language. If you work with databases, you'll know SQL. OGR allows you to run SQL commands on your source dataset without having a database. So you can just specify your query as a SQL command, and it allows you to run that. You can do select, where, etc. In OGR to OGR, we have one option called -where. -where will allow you to select specific subset of data by specifying a where command from a SQL syntax. So when you write a SQL command, you'll say select star from this layer where country equals to Japan. So now we can say, I just want to specify the where part, and I can extract the subset. So let's see how to do this. Up arrow key to get the previous command. We'll just add one more option here. We'll just say where. And here I have to write my SQL query saying, how do I define where? And we'll say country equals Japan. Right? So I'm just going to add that. Let's run this. Oh, I need to forget one. So say country equals this. So now it says, take my world cities.csv, turn this into a spatial layer, assign the CRS, but save the data only where the country equals Japan. Let's go to QGIS and load this data. And you can see I only have the data for Japan. And you can see all my points are from Japanese cities. So now we're starting to do something useful where, imagine you have a very large vector layer, maybe somewhere on the internet. You want to extract a subset of it, convert it to a different projection, and save it in a format. You can now do this with a single command by specifying something like this. So try this out. Do it for your own country. So here we have the 2.1.4 extract a subset. Here we have country equals India. You can change the country name to any country. If you don't know how your country is spelled, open the worldcities.csv and see how your country name is spelled. So for United States, I think it's spelled as United States, but it might be different spelling for your country. So if it gives an error, make sure you have your country spelled correctly. Let's see the data that we came up. If I open this data, go to properties in QGIS and go to the fields, it shows me the data type that OGR determined automatically based on each type. It says the city is a text, city ASCII is a text, lat is a decimal, and so on. Here we have a problem. You can see the population came up as a text value. There were some values with null values, and OGR just assigned it as a string. And this is a problem. If you want to do some mathematical operation with this data, it doesn't work. So this came in as a wrong data type. So we can also adjust that. We can say, I want to import certain fields with a certain data type. So let's fix this so that we import this in the correct format. You can also use GDAL info to check that. You can say GDAL info -so.al worldcities.gpackage and for OGR info. And it says all the column names. I can say population is a string. I want to fix that. So back to our command. Let's remove the where column. Instead of just a where query, we can actually give a full SQL query. We can say dash SQL. OGR to OGR has support for a full SQL query where you can give a full SQL statements. So now I can say, I have my data layer worldcities.csv. Let me run a SQL statement, and we can do the data type conversion as part of the SQL statement. So let's run this. I can say my SQL statement looks like this. Select city, country, population from world cities, where country was India. So this is my SQL statement. I want to select these three columns, select city, country, population. This is how you run a SQL query. Select these three columns from world cities where country equals India. So this is a where part. This is a SQL part. Here we know that when we do not specify, the population comes in as string. So we can use the SQL cast function and say cast this population as integer. So this is how you do tell SQL that this should be an integer, and we'll just say my output name has to be population. So this says it'll select the city column, country column, take population, convert it to an integer, and then save this. Let's run this, and we have our output. Let's check the output. Let me make it Japan so that it's consistent with the previous step. If I open the attribute table, you can see now I only have three columns. I selected a subset of columns. So that's what I wanted for my output. And if I go to my properties and check, you can see that my population is now an integer. It came in as correct data type. And you can see what we've done. Again, we are starting with CSV, converting to GeoPackage, assigning what becomes a point geometry, assigning the CRS, and running a SQL statement to select the subset of columns and transforming the data type of one of the columns. Try this out. This one is the next command in section 2.1. We still have a little bit of problem. So remember, we are still naming our output as world cities. I want to change that. I want to change my output name of the file as my cities. So let me just change my output name as mycities.geopackage. So in QGIS, now I have this new file, mycities.geopackage. And I can add it to QGIS. You can see when I add it, it says my cities, world cities. So GeoPackage is a file format which can have multiple layers inside the same file. So we have the outer file, which is called my cities, but the layer inside that is still called world cities, because that came from our original data set. So you can see my data set name was world cities. So it added the layer as world cities. And this is not very useful. So I want to also change the name of the layer that gets added. So if I add this thing, it should just add it as my cities and not the world cities. So let's go back to our OGR to OGR. We have one option here, NLN. NLN stands for new layer name. It says assign an alternate name to the new layer. So we are creating a new layer from the CSV file. The default name becomes world cities. If you want to change that, you can specify the NLN flag. So I'll now change my command line to say, this was my last command line. I'll add NLN my cities. That means name my output layer as my cities as well. Let's run this. And now I have my final output, mycities.geopackage. You can see my layer name is also my cities. So we have one command that does like 6 different things. And hopefully you understand this command. If you come across a command like this, you know how to now interpret this and kind of look at different options and see what it's doing. And your job when you're building pipelines is saying, figure out this command one step at a time, open the data layer, add one more option till you get the output you want. Finally, once you have it, this is your command line. Now imagine you want to do this as a pipeline. You want to read this data from internet every day and load it into your database. Well, you have a command line that does all of that for you. This would easily be 20, 30 cells of a pandas notebook. Right now we have a simple command line that does this, and it's much easier to run in production. Just do conda install GDAL and run that, and be able to run this on any server.